I jump into this, I want to kind of talk about why scale is important. In physics and science, basically, and everything, why is scale something that we need to know about? And in physics, it's basically because scale is something that helps us talk about a similar unit like something like a meter, a gram, or a liter, but go beyond just a single gram or a single liter. An analogy I often like to make is imagine a world where we had no other money than just a single dollar bill, and there was no other way of paying anything. It would be kind of annoying to go and buy something that's $34 if all you had was one. And imagine buying something even bigger than that if all you were able to carry was single dollar bills. Things would start to get kind of annoying and difficult to understand. So that's why we use this thing called scale. And in scale, it's something you're probably familiar with, we have several different prefixes. So everything I'm writing right now is a prefix. It goes before the base term like gram, meter, or liter. So kilo is a prefix, hecto, deca, clean that up, deca, and then we have our base unit, and I'll talk about what I mean by that in a second. Deci, centi, and milli. So these are the 6 basic prefixes that we're going to have when we're talking about scale in terms of the metric units. So the base unit is basically when we're talking about just things that are just measured in grams, like kind of like that whole single dollar bill thing I was talking about, just measured in meters, or just measured in liters. So if you want to keep it in meters, grams, or liters, you can do that, and you can stay in the base unit. You don't need to add a prefix to it. But the only problem is when we're talking about something that's 200 kilograms, well, we don't want to be having that conversation in grams. We want to be talking at least in kilograms. So basically, but what do these prefixes mean? You can't just slap something on a base unit and expect it to make sense. You have to know each one of these has a numerical value. So kilo, if somebody said that they had 1K of something, you might think that they have 1,000 of something, and that is right to think that. Hecto is 100. Deca means 10. Deci means 0.1 or a tenth. Centi means 0.01 or a hundredth. And milli means 0.001 or a thousandth. So you can kind of see how the top and the bottom of this interchange. So basically now, what does it mean? Because it's kind of confusing. What does it mean if you have a kilogram, or what does it mean if you have a kilo of something? It basically means that you have 1,000 of your base unit. So if I have 1 kilogram, that is the same as saying I have 1,000 grams. And it works for any other of these. So if you have 1 milligram, it's the same as saying you have 0.001 grams. And this is why it's important to understand that why this scale works. Oftentimes people will look at something like milli and be like and get confused when they look at something like kilo, because there's such a big difference between the numbers. But if you can kind of think about it this way, it helps kind of make some sense. And a really big important thing to understand is that a kilogram is going to be large. This is a large scale, so you're going to have these are going to be some of the biggest units that we use. And a milligram or a millimeter is something incredibly small. So if we think about something like a meter stick, so we'll say that this is 1 meter. Well, we could measure that in basically every single one of these units if we wanted to, but it wouldn't make sense to measure it in kilometers. It wouldn't make sense to measure it in millimeters. But something that does kind of make sense is centimeters. So how many centimeters are on a meter stick? It's actually 100 centimeters. So if you kind of think back to what we were talking about before, if you have 1 centimeter, that would mean that you have 0.01 meters. Well, how many 0.01s would it take to get to a full 1? It would take 100. So that's how you know that there are 100 centimeters in 1 meter. So this is just kind of a basic introduction to how we use scale and how we can kind of bounce back and forth. And it's even a little bit talking about converting here too. But more on that later. Thanks, guys.